Hello there, my followers or subscribers, or whoever watches this. I want to show you a new project. This time I ran into a problem or situation that eventually some of you may have experienced. I have this really nice voice recorder here. It's working really well, I like it, I use it occasionally. It's having a very good quality and it's all digital, there's no cassette or anything. It's all on digital memory. And this digital voice recorder has a problem. It has a built-in speaker which is very good. It really has a decent sound quality for its size, but sometimes I would like to have it a bit louder. And the simplest solution to that is, well, connect a bigger speaker. The problem is that the output of these devices on their headphone jack is not very high. You do not have a lot of power on the headphone jack. I will show you that. I have a recording here and I've made an adapter. As you can see, it connects my speaker to the output from this device. I push play now, and you should hear it eventually. Eventually you could hear it. I'll try it again because there's somehow a little bit of dodgy contact. Where was it? Ah. Okay. I can hear it. I can hear Testaufnahme, Testaufnahme, Testaufnahme. You may eventually have very silently hear it in the background, or have heard it in the background, but it's so silent. That's the problem. So, YouTuber Blechy, you may remember him from the TV amplifiers, TV transmitter, not TV amplifier, TV transmitter circuit, has found a solution to this. He has made a small Class A amplifier. And what I'm going to do now is I'm going to hook up the amplifier to my loudspeaker and to my voice recorder, and we should be able to hear the signal quite good then, because as it's the job of an amplifier to amplify signals, this is pretty much what the amplifier is going to do. It's going to drive the speaker with much more current, and hence more current, the speaker is going to produce a louder sound, a more audible sound. I thought about cutting the video, but I think if I do it live, it's more authentic. Anyhow, if you have time, please subscribe to Blechy's channel. I will show you later how his name is written, so you can subscribe to him. But now let's return to the circuit itself. Here you can see, it's a bit, lots of wires, a bit messy, I'm sorry for that. But as you can see, I've now got my circuit set up right here. And the red and the black wire is of course the supply voltage. So I'm going to show you now how it works, and keep in mind that I'm going to hold the voice recorder outside of the picture, because as you can see, the amplifier and the loudspeaker pretty much are taking most of the space that is available. And I don't want to have things overlaying each other, overlapping each other. I just want to have it tidied up. Okay, now connected to my power supply, which I have set to about 9 volts. I connect it. There we go. It's a bit dodgy with the contacts. Okay. Now it has contact. And now outside of the camera, or I try to get it in camera, I push play again.
Testaufnahme, Testaufnahme, Testaufnahme.
Well, and that was clearly hearable. So as you can see, Blechy's audio amplifier is working really well. Before I do measurements on this amplifier, I want to give an explanation about these types of amplifiers. As good as it works, it has a downside. It's a so-called Class A amplifier. What does Class A mean? Class A relates to that the speaker or the output is driven directly by a single transistor. In Class AB, you would have another transistor up here, but this is just Class A. Why do people build Class A amplifiers? You may ask it. Well, on the early radios you used these electron valves or electron tubes. Among collectors it's pretty common to state that these amplifiers produce a very specific, warm and special tube-like sound. They call the new Class D amplifiers, which you would find in your phone or a modern stereo system, they call them to have a dry sound, a typical sound. It's hard to describe, but Class A amplifiers are stated to produce a very warm, soft and tube-like sound. Blechy wanted to design an amplifier used, for example, on his laptop So he can listen to his music over a speaker, and the music kind of gets converted into a so-called warm sound from the amplifier. The downside of these amplifiers is their efficiency. Class A amplifiers have a very low efficiency. You put in 100% of power in terms of electricity and current, but only 15 to 17% actually end up in the speaker. The other amount of energy is converted into heat by the transistor itself and by the dropping resistor, voltage and current dropping resistor. Still, let's say you put in 10 watts, which is a lot, you'd still get at least out a bit more than 1 watt of audio. And 1 watt in a good speaker is definitely enough to not only supply a room, to make enough noise so your neighbors will complain why it's so loud in your room. Anyhow, I want to talk a bit about the theory of these amplifiers, and therefore I have drawn a little schematic, because later I want to explain the schematic how it works. As you should know, there are MOSFETs and transistors. Maybe this drawing is wrong, maybe the arrow is showing in the wrong direction, I don't know it. I was a bit in a hurry when I made this video, so this should be an N-channel MOSFET, maybe the arrow should show in the other direction, but just imagine this is a so-called N-channel MOSFET. Here I have a simple circuit with a so-called control circuit and a load circuit. The load circuit is the light bulb. The light bulb can be a small flashlight light bulb, or it can be a huge car headlight light bulb. But it's driven with 9 volts from, let's say, a small 9 volt battery. Of course, the small 9 volt battery won't really drive a 50 or 100 watt strong light bulb, but using the MOSFET as an amplifier, it is able to do so. Actually, if you connect the 9 volt battery here, the car headlight lamp, for example, would light up. The MOSFET would even stay cool if it's the right type. If you disconnect the battery, the lamp would stay on, but slowly would dim. This is because the MOSFET works with electric charges, and actually you would have to add a resistor between here and here, so it will turn off as soon as you remove the 9 volts. Let's say this resistor is a 100 kilo ohm resistor. If you do the math, you will see that there is barely any current flowing into the so-called gate of the MOSFET. Here I have exactly the same circuit, but this time I'm using a transistor. This also is the car headlamp, or headlight. There's my small 9 volt battery, and this is also a 100k resistor. Well, if you connect it up like this, literally nothing will happen. All that will happen is that eventually, after some time, the transistor will get a tiny little bit of warm, or will warm up, but nothing else is going to happen, because unlike a MOSFET, a transistor is current driven. That means that you have to drive a lot of current into the so-called base connector to get this thing working. Whilst the MOSFET, you can, let's say, use a microamp to drive it and it will work. So you may ask, if MOSFETs are that awesome, why didn't Blechy use a MOSFET in his circuit? Well, there's a problem with the MOSFET. The MOSFET, unlike the transistor, which only requires 0.7 volts to be conductive, or 0.3 volts in a germanium transistor, but these are silicon transistors, you will need a lot of voltage on a MOSFET. And also, transistors are usually designed to be operated in the so-called linear mode. That means you can make them half conductive and they are okay with it. MOSFETs also can be operated in that state, but actually they are more designed to act like a switch. Either turn the current on or turn the current off, and not like turn it on a bit like a transistor. So what has Blechy designed here? If you look at the amplifier, you can see that there are different stages. We do have small signal transistors. These are very tiny transistors. They don't really have a lot of power, hence their name small signal transistors. And we have a huge, even you could call it high power transistor, which is stronger than the 2N3055, if you may know him. This one can take more current and more voltage. But the problem is that this transistor does require a lot of base drive in terms of current to actually operate. And if you are knowing the basics of electronics, you will sure know that a so-called collector circuit, this is pretty much what we have here, is going to amplify the current. It doesn't amplify the voltage. The voltage amplification is around 1. So let's say you put in 1 volt here, you get out 1 volt there. But if you put in 1 volt, 1 milliamp here, you get out 1 volt and 50 milliamps here. So the current is amplified. And you sure can imagine that our voice recorder, which I showed you in the beginning of the video, is not going to put out a whole lot of current on its headphone jack. So what Blechy does here, he uses multiple stages for different jobs. Look on the lower things, I have it in German and the lower one is in English. So the first stage is the bias. It defines how much current is going to flow over the load resistor and the loudspeaker. Also, the current or electricity that flows over the speaker and the resistor is affected by the input signal. This was my voice recording that you heard. One single transistor isn't really delivering that much of current, so he used two other transistors in parallel to amplify the current again, and with the amplified current finally drive the so-called final amplifier. It's a very smart circuit actually. And another thing I'm going to do is I'm now going to make a measurement. I want to see how much power this thing puts out into a typical 8 ohm speaker. So in cars you have 4 ohm systems. The speakers have an impedance of 4 ohms, and in home you have 8 ohms. The reason for that is that in cars you have a rather low voltage, and in home systems you have a higher voltage, so you can use longer wires and the speakers can have a higher impedance, but you don't need that much current. Anyhow, I'm going to set up things. I will pause the video because I have a lot to set up, and then we continue with the power measurement of this amplifier. Here's my setup for measuring the power. You can't see everything. I'll show you. Here's my AC generator. It just produces a sine wave, AC sine wave. Here's my volume control. Here's the audio amplifier's input, loudspeaker, and I've hooked up 2 things to it. First, these wires go to my oscilloscope, and the other wires go to a multimeter which measures the AC voltage. How do you measure the output power of such an amplifier? First of all, you need to know your load. In this case it's an 8 ohm speaker and a 10 ohm power resistor. You calculate them together and get maybe 5.5, something like this, ohms. This is your load. The next thing that you're going to do is you're going to put in a sine wave and crank up the volume. Of course you use a resistor instead of a speaker because it can get quite loud. You crank up the volume and watch on the oscilloscope until the sine wave starts to distort. Adjust it a little bit lower before it distorts and measure the voltage. Then you have the RMS voltage if you measure it with a multimeter, and with this voltage over the formula, power equals current times voltage. With the power equals current times voltage formula you can figure out how much power this amplifier has. I'm going to do exactly this. I'm going to connect the amplifier to my laboratory power supply, and you can barely hear it buzzing, but I can tell you the membrane or the cone is vibrating really a lot from the 50 Hz base. And if you look at the oscilloscope, you can see it's a sine wave. Now I'm going to crank up the volume, and this is not good. This is clipping, and you want to have it a nice and smooth sine wave. So you want to have this bow. If it goes like a straight line, you don't want it. You want to have a bow. And then you look at the voltage. So it's still not perfect. Let's reduce it a bit. Now it's good. We are having around 1 volt. 1 volt AC on our load. And the next step that you're going to do to calculate the power is you write down the values that you measured out, and then you can calculate the power using this. So here I wrote down the values. We have our resistor, which consists of the 10 ohm load resistor and the 8 ohm speaker, and we do measure 0 volts and 1 volt. As I said, use the formula to calculate out the power. But you also can do a imagination or foresay the power. You know that a Class A amplifier has an efficiency about 15 to 70%. Not 70, 17. So below 20%. So just take the overall current that's fed into it, the overall voltage that's fed into it, calculate out how much this power is, and then take like 15 to 17%, and you have the power of this amplifier. Anyhow, this is pretty much the final of the video. Here's the circuit again. If you want to build a nice sounding audio amplifier, you can add this capacitor for better sound. That's what Blechy told me. Feel free to build it. Oh, one more thing. Blechy would appreciate it if you would subscribe to his YouTube channel. That's his name. He makes videos in German, but he also puts in English written schematics into the German videos. So you are able to build the circuits he makes. Thank you for watching and have a nice day.